Today, we're diving into a revolutionary new material that could seriously change everything. And I mean everything, from military vehicles to high-speed trains. It's all about making things lighter, stronger, and a whole lot smarter. Let's get right into it.
So, let's start with the big question, the one that armor technology has been trying to solve for, well, centuries. How do you stop something moving incredibly fast? It doesn't matter if it's an arrow, a cannonball, or a modern bullet. The physics are the same. You've got to absorb a ton of energy in a fraction of a second.
For the longest time, we've really only had two main answers to that problem. First up, steel. Sure, it's strong, but man is it heavy. It just bogs vehicles down, making them slow and guzzle fuel. The other option, ceramic. It's amazing at stopping that first hit, but it's brittle. One impact and it shatters, leaving a huge weak spot. So yeah, we've needed a better way for a long time.
Well, it turns out that better way comes in the form of a composite material. The easiest way to think about it is like a high-tech sandwich, where every single layer has a crucial job to do, creating a shield that is way, way better than any single ingredient on its own. So, what's in this super sandwich? Okay, first, you've got layers of high-strength fabric, kind of like a super advanced version of what's in a bulletproof vest. Then, holding it all together is a special plastic resin that's incredibly strong and, really important, doesn't melt easily. But the real magic, the secret ingredient here, is that third component, graphene nanoparticles.
And graphene, well, this is where things get wild. It is literally the strongest material humans have ever made. When you mix tiny bits of it into that plastic, they create this invisible net inside the material. So when a projectile hits, that net instantly catches the energy and spreads it out across the entire panel. It's what keeps the bullet from just punching right through.
And when you put all these ingredients together, you end up rewriting the rules of armor. You can finally solve those three huge problems that have been a thorn in the side of engineers for decades: weight, the ability to take more than one hit, and protection from explosions. First, let's talk about weight. This new composite is 30 to 50% lighter than steel for the same or even better protection. I mean, that's not a small tweak. That is a massive difference. A vehicle can suddenly go faster, use way less fuel, or carry more people and gear, all because it shed all that dead weight. The second huge advantage is survivability. Remember how ceramic shatters? Well, this stuff is the opposite. It's designed to absorb the force. The source material had this perfect analogy for it, calling it a shock absorber for bullets.
And because of that internal graphene net spreading the energy around, the armor doesn't just catastrophically fail. It can take multiple hits, even in the exact same spot, and keep on protecting. For soldiers in a vehicle, that kind of resilience is, frankly, the difference between life and death.
And finally, blast protection. When an IED goes off, you've got two big dangers: the shrapnel flying everywhere and that invisible, violent shockwave. This composite material acts as a buffer for both. The fabric layers stop the shrapnel, and that graphene-infused plastic just soaks up the shockwave, basically unplugging the crew inside from the force of the blast.
But you know, a material this incredible isn't just for armored vehicles. I mean, when you have something this strong, this light, and this fire-resistant, it just blows the doors open for a ton of other uses. Not just in the military, but in our everyday lives too.
Just think about the other military applications for a second. You could build instant protective bunkers overnight with walls that are light enough to move around. You could make aircraft and drones lighter so they can fly farther on less fuel. And of course, you could have body armor that offers better protection, but doesn't weigh soldiers down.
And this is where it gets really exciting for all of us. Imagine high-speed trains that are not only more energy efficient because they're lighter, but way safer in an accident. Or firefighter gear that gives them even better protection against intense heat. You could even build disaster relief shelters that are fireproof, hurricane-proof, and can be put up in a flash.
Okay, so let's circle all the way back to that first idea and see what it actually looks like when you build a vehicle from the ground up with this material. This is what's called the Composite Armored Vehicle, or CAV.
Now, this isn't your normal truck with some armor plates bolted on. No. The entire vehicle is the armor. The frame is carbon fiber, the body is our graphene composite, and then on the very outside, there's a thin layer of super hard ceramic designed to break up a projectile before it even gets to the main armor. It's a whole integrated system.
So what's the payoff for designing it this way? The composite armored vehicle is between 1,000 and 1,500 kilograms lighter than a regular armored vehicle of the same size. Let that sink in. That's over a ton of weight that's just gone.
But here it is, maybe the biggest game changer of them all. Because you've replaced almost all of the steel with composites, the vehicle becomes pretty much invisible to magnetic mines. Those mines are triggered by a huge chunk of metal, like a normal truck. This design makes one of the deadliest threats out there completely obsolete.
Now, all of this sounds incredible, I know, almost like sci-fi. But what does it really take to get a technology like this out of the lab and into the real world, as something you can actually build and sell?
While the road to making this real is long, and it's expensive, it happens in 3 big stages. First, there's all the research and development to get the formula just right. Then, you have to actually build the first full-scale prototype. And finally, you have to put it through a whole battery of super expensive ballistic and blast tests to prove that it actually works.
So, what's the price tag on this kind of innovation? Well, the estimated cost to get a fully certified vehicle like the CAV ready for market is somewhere between $8 and $35 million. It is a huge investment, but it also shows you just how complex and groundbreaking this whole idea really is.
Which brings us right to our last thought. We've seen how this material can protect soldiers, make travel better, and even build emergency housing. At its core, this tech is a fundamental building block that just makes things lighter, stronger, and safer. So the question I want to leave you with is, what problem would you solve with it?